of our opening slide would be the same. You're in the same room?
Next.
Was that next? So same slide, you've seen this, I think we're okay for it. So what I hoped we could do was learn a little bit about the GLOBE program, learn a little bit about the Earth System Science Collaborative, and then anybody that was interested learn how they could be involved. So I have one ground rule, lots of questions. So Mary, you're on the spot. Dave's keeping track of Zoom, but unless you get some help from there, every question has to come from you. And if you don't ask questions of me, I'll ask questions of you. So that's so. This is our, the GLOBE program is a long-standing program. So this is actually the 26th year of this program. It has some really unique sponsors in that NASA right now is the lead sponsor for the GLOBE program, but also NOAA is a sustaining partner. I can tell you a little bit, well, let me go through all of them, then I'll tell you why they different roles. So NASA and NOAA on the science side, NSF on the teacher side. So NSF gives us money to be able to take this work and be able to work with teachers with it. And then the Department of State is the other partner in this. So GLOBE is an international program. You'll see a couple of slides up, you'll see kind of the extent of the reach of the GLOBE program. NASA is a lead. NOAA used to be a lead, but when questioned at the congressional level about the monies they were committing to the program, we struggle a little bit to get teachers to submit the data that their kids collect. And so NOAA fell back a little bit to becoming a sustaining member. So they're rooting for us, but they're not putting as much money into the program directly. What they are doing is making GLOBE on their other grant programs. You get extra points if you're using GLOBE protocols, which is kind of their way to sort of draw people in, which has been great. So it's an international science program with the idea of crowdsourcing. So what I like to say is that GLOBE was citizen science before the term citizen science was ever invented. The majority of the data that scientists have to be able to work with is remotely sensed, so satellites. So when I mentioned Landsat, we're going on 50 years. Landsat 9 will give us 50 years of continual Earth monitoring from satellites, which is pretty cool when you can look at a spot and be able to see what's happened over 50 years, how it's changed. That data, though, doesn't have as much of an impact or as strong a use until somebody actually goes to these places and ground truths the data. So from a satellite, it looks like it's green, and then we send kids out there and they find out that that green was a pine tree, right, or a stand of pine trees. Then scientists can actually use that data in a very different way. So kind of the history behind this is GLOBE has spent a lot of time working with scientists and developing protocols that a teacher can understand and that kids can use with a high level of efficacy. So now we have this level of confidence that kid goes out and collects the data the exact same way, whether they're in Buffalo or Bulgaria. And now with that level of efficacy and those things, the data has, we can have some confidence in using that data and stuff like that. Their GLOBE, what I like to say, GLOBE doesn't like to hear me say this, but I can say it anyway. GLOBE is not a curriculum. GLOBE is a set of protocols that teachers are able to build into curriculum in their classrooms. And it's a K-16 sort of, or K to grade, I guess, kind of thing, because we're using GLOBE protocols as part of our community outreach in citizen science. We're using the exact same protocols to be able to do that. So it's consistent, it's scientific, it's ongoing, and really pretty cool. So the other piece of GLOBE that I think the reason why you hear about the Earth System Science Collaborative is that GLOBE kind of acts at a local level, a regional level, and a global level. So we're able to be able to connect But a really great example is the day in the life. Rhinestone Woods, the DEC has run a day in the life for a whole bunch of years. And now we partnered on the last two NOAA BWET grants to build GLOBE into that. So at a regional level, we have data, but we contribute that data to the global level. You know, we have lots of things, lots of ways that this is said in the science curriculum, but the idea of trying to develop environmental literacy and stewardship in particular. So GLOBE has served well for the past 26 years in doing this, and hopefully to be able to have a sense of discovery. So you see some pictures. These are kids out on Lake Erie, down near Dunkirk, collecting data, and then I don't know what I put in, but it's kind of it's been a great effort. So GLOBE right now is in 126 countries. Easiest way to view this map is the areas that are in gray are the countries that are not participating. There's some that are, have some different reasons for not wanting necessarily this data, with the idea, Mary, that if students are collecting this data and you get, say we're collecting water quality data, and you find out that the water that's part of your water system doesn't necessarily demonstrate high quality. There are some countries that don't really want that conversation to start. But pretty good coverage of the entire world. What I like to point out is my contribution to countries that don't participate is this country right here in Central America, Belize. Belize is a wonderful place. We've had, I think we're going on 15 years of a partnership between SUNY Fredonia and Belize. One of the years I went 8 consecutive years in January to take students down to work there, and the Secretary of Education, I was sharing with Dave at lunch, it's such a small place, but the Secretary of Education, I met him every year, and we stayed at the Radisson, and he would come there to work out in the gym, so that's how I met him. He emailed and said, you're coming this January and we're trying to reform our science curriculum. Would you be willing to work with our science teachers? And I said, well, I'd love to work with your science teachers. So what they did is they brought every science teacher from the country to their training facility in Belize City so I could work with them. And because I think GLOBE is a perfect way to change the way we did, I trained every teacher in GLOBE protocols. So I came back, sent my email, shared out what I did, waiting for my attaboy from NASA, and got an email back saying, Belize isn't a GLOBE country, because I didn't realize it is a really big deal. The reason why the Department of State is there, it's a signed agreement between their embassy, NASA, and so now I trained them all in GLOBE, so they don't have to have that partnership. So I take great pride in the fact that I created this little great spot in Central America. No, we're going to continue to talk about it. So 126 countries, but maybe the more amazing thing is over 207 million data points are in the database. So across the 26 years, that quantity of data has been put in for teachers and students to be able to use. So I think just an incredible number. GLOBE has developed a whole series of educational pieces. Dave and I have similar, my job at Fredonia is similar to Dave's work here at Buff State. So in our childhood methods, science methods class, we rely heavily on the elementary GLOBE series. So they created readers. They say that they're targeted at 4th grade. I think in New York, by our standards, kind of a 2nd or 3rd grade reading level for that. But developed activities for that group of scientists to be able to do that parallel what a high school student would be doing. So just taking an example, precipitation and weather, right? So one of the guys there actually has kids, kindergartners. We have a school district that partnered kind of across their elementary school. So the kindergarten students go out and read the rain gauge. You only have to read the rain gauge once. So kindergarten takes advantage of doing that and then shares that data with the high school or science teacher. So at kindergarten level of data analysis, right, we can use this and talk about, you know, sort of the more or less or what's happening across the school year, sort of a trend. The high school or science teacher can use that data to talk about climate and shifts that way. So very cool. Lots of resources for helping students be able to look at data. So that 207 million data points that are in there. Ways to be able to do that in a kid-friendly, sort of developmentally appropriate way. Also, lots of supports using NASA assets to be able to build those into the classroom. So these Earth system science activities, like that. What I usually like to say is, let me just go back here. I don't know this. I've done a globe. I was doing, when I was a high school teacher, I was using globe as part of my work. So the 24 out of the 26 years I think I've been involved in globe. I think probably what happened was they developed all these protocols, they rolled them out to teachers, and then some teachers said, well, there aren't classroom activities. So they developed activities that go around these, but there are much better curriculum connections that take advantage of globe. What I would say, like a national curriculum like Project Learning Tree has incredible activities, but doesn't do much science, where Globe is all about science and their activities maybe don't rise to the level of Project Learning Tree. So lots of partnerships around that. What we're hoping to be able to do is take advantage of what is 21st century thinking skills. So the ability to have access to the quantity of data that kids have advantage, the teachers have access to be able to do that, is sort of falls into this big picture thinking that, you know, we heard it a little bit in the speech, in Jennifer's talk this morning, you know, the idea that we need to develop this ability in students to be able to see across goal. You know, our lived experience here needs to be in the context of a lived experience that's much bigger. And so having access to that and being able to partner across globe classrooms around the world, which, you know, we've had a number of teachers in Western Europe partnered around things, you know, water and air quality and land cover with classrooms in Brazil and sub-Saharan Africa, things like this. And for science teachers in New York State, it's a really nice match to the new science standards to this list. So, any questions yet, Mary? I know it's just hard to believe, just awestruck by this, and just so really the globe science part of this is really learning science by doing science. So again, globe is not big on activity-driven kinds of things, but the pieces, the protocols that are developed for teachers to use in the classroom have a lot of teacher content that's built behind it. So the science piece is well established, and also the reason behind why a scientist wants this protocol to be used. So it went, I think, initially from having lots of remotely sensed data, like from Landsat and other NASA Earth science missions, to now particular scientists saying, hey, we need, it would be great to have teachers and students collecting data. So the most current version of that is a mosquito protocol. So asking kids to go out and find places where mosquitoes may be laying, their eggs and where larvae are developing, with the idea of identifying by just sort of species level identification of mosquitoes that carry mosquito as a vector-borne disease. I apologize to the scientists on this every time I see them. I'm not actually on their advisory board now. I've apologized so many times. But when they first pitched this protocol, it was really important for the scientists in Thailand and in areas when they were looking at malaria, yellow fever, and eventually Zika and things like that. But I never thought that we would see connections just to be self-serving in Western Europe. But the mosquito that carries the vector for malaria and Zika and yellow fever is the exact same mosquito for us that carries Eastern equine encephalitis, carries, West Nile virus, all that. So there are, identifying that vector is really important. And so the scientists have used that. Now we have millions of land cover observations that are connected to where these mosquitoes may be laying their larvae. And now we're using those images that students are taking to try to build a machine learning design to be able to take those images and be able to identify it. Because we can teach a kid just by the shape of the larva to say it's a species, Aedes aegypti, right, which is one of the most common ones around here. They can identify that, but then there are subspecies that are of real interest to scientists. So being able to have a kid take an image, that image goes up, automatically loads if you use the app, and then have that machine learning algorithm be able to look at that and be able to go to a subspecies. So pretty cool. The 50+ protocols across where the Earth system idea comes in is that we're looking at the atmosphere, we're looking at the stuff that we're standing on, the soil, hydrology. Very, very cool. Kind of looking at it as a system. So then talking about how you can use Globe in the classroom. So big idea is that Globe is more than a sum of its individual protocols. So being able to, so my methods class this coming week will be identifying a land cover site, using that land cover site to then make atmosphere observations, cloud observations. So putting all these protocols together to be able to come up with a bigger piece than just individual pieces. The idea we hosted, you'll hear more about a student research symposium that we hosted here in Buffalo, but it's the whole Northeast Mid-Atlantic states funded by NASA to be able to bring student research. So if we want students in our new standards to learn science by doing science, this is a great opportunity to give them protocols to be able to follow, to be able to support them, but also have a value added contributing to the field. So that sort of the big idea behind student research. So it's just, if we're not sure what we mean, it's really about remotely sensed data being ground truth with students. So this is a tough example to do now because cameras on phones are so good that you can't get a camera that pixelates an image. No matter how close you zoom in, it still looks like a picture. But if you had my original flip phone that had the camera in it, if you zoomed in, you could see the red balloon, right? You could see these pixels. Everything in Globe starts with this idea of identifying a pixel in a landscape image. So a pixel in a landscape image is 30 meters on the side, so which is pretty big. I mean, it's twice this. It's a diagonal of this room and then a diagonal of this room. It's 1 pixel in that landscape image. So it kind of works on that. It's controlled, so it's all ground truth, but it's also geo-referenced. So we know when my students on Monday morning are out there collecting their data, when they put that data in, that data gets dropped to a geospatial location, which is pretty Mary, you're not doing very well with these questions. Remember that first slide, one ground rule. So the other piece that's important to remember and why that ground truth piece is there is that scientists actually are looking forward to having this data. So we are, NASA is very interested and excited when scientists are actually using GLOBE data as part of their published, peer-reviewed presentations and papers. So it's really contributing to that community. It is, scientists consider it high-quality data. We've done everything, a whole bunch of efficacy studies have been done on this, where we have a group of kids collecting data with the instruments that high school, middle school, elementary teachers can afford to have, and then somebody with scientific grade instrument next to them, right? And within that margin of error between the two, it's negligible. So that's how we got to this high quality data piece. And then I like to share the story that, to me, it's absolutely amazing how welcoming the NASA scientists are to taking students' questions. So we were doing a study with a middle school around a particular, it's called soil moisture activeness. So there's a satellite up there that actually can measure soil moisture content 2 inches below the surface. And they needed to have it, we need to have ground truth data to be able to say the image, be able to interpret that image. So 7th grade boy in Oklahoma had done this data. And then there was this anomaly. His data didn't really match the data that they were getting from the satellite. So the lead scientist is on this call, and we're all doing this thing. And Brian asked this kid, points out to this kid that the data didn't match. And this very professionally toned young man says, this is what I did. I did this, then I did this, then I did this. Is that right? And Brian says, yes, that's right. He said, then my data is not wrong. Right. And it was really interesting. Brian, what actually happened, right, was the discovery of an aquifer that they did not know that was there. So basically, a path this big, right, is really tough to pick out of the satellite, except if you take your data in that path and get that data. So very, very cool. I think I always overthank maybe these scientists for doing this, and they loved it. I mean, they flat out said, this is way better than what I was going to be doing. They might much rather talk to students than do what NASA wants me to do. So, so back to that 207 million data points that are in there. Teachers have access to this data really in almost any form that they want it. So if we were welcoming math teachers in here, having real world data that we ask students to analyze, to graph, to do whatever, they have access to that data. You can print out the graphs, it'll generate the graphs for you if you want to do that. Kind of my area of interest is how we can represent these on maps. So how do we see a spatial relationship between these data? All of those are available on the website, and it's real-time data. So if you were to log into globe.gov, you'll see data that is minutes old. Whatever the recycle rate is on the database, it gets pushed out to the website. So it's real-time data as well. I'm not, so I'm going to cop out a little bit. I'm not 100% sure that if we flip screens, we're going to get back to being able to share. So I'm going to pretend that I showed you some data, but it's actually very cool. I talked a little bit about this before. We started to focus, the pieces of having a student act like a scientist, right? Collect data, analyze that data. There's another piece which is communicating that data. And so we started to host what we call regional science symposiums, not a science fair, a science symposium. So students present their research to other students, to scientists, to the public, and we host them regionally. So there are 7 globe regions. I represent the Northeast and Mid-Atlantic. So we've hosted SRSs at NASA Langley, at Boston University. We hosted one in Buffalo, hosted one down in Philadelphia at Temple. And basically NASA pays for the teachers and the students to come, present their data, get that feedback. We moved away, it's not a science fair. We don't award any ribbons or anything. And I think there's some complaints about that. Complaints from teachers, quite honestly, that we don't recognize what was the best presentation or the best poster. But it's really interesting to listen. They all put up their work, and then all the adults have to do their work. And it's only students going around giving peer feedback, talking to each other, right? And we have a high school room and a middle school, you know, we try to not make it be anything. And it's really interesting when because I don't, not much of a rule follower, but it was really interesting to go back into that room and listen to the discussion between the students or the students afterwards, you know, grabbing somebody and pulling them over to show them somebody else's poster because it was something that they, you know, on their poster that now connects to this poster. Just very, very cool. We also have the ability for them to be able to share. No way, a question.
I have a question. You said NASA will pay for the students to go. Is there any criteria for that, or is it just whoever signs up who's participating?
So yeah, that's a great question, Julie. So what it is, the teacher, so we'll use Amy Lauer, Amy, a master teacher from here. So Amy's gone 3 or 4 times, has taken students. So Amy will have students that are doing student research, has to be using globe data, but that's a really simple thing. And then they just put in that they'd like support. The last version that we ran before pre-COVID was the Boston University one, and they paid for Amy, her husband, because we had a mixed group of boys and girls. Greg went as a chaperone, and then 6 students. Okay, cool. Flew them to Boston, put them up and paid for their food and their hotel, and then flew them back too. That was important. So round trip.
Awesome.
Yeah, it is awesome. We have a virtual student science symposium, so they can also put into that, and now it's an international pool. So they have scientists from around the world that are reading their research and giving them feedback. What we're going to try to do, right now, our current idea is that we will run a regional SRS, sort of a local SRS at SUNY Fredonia, like the first week of February. The virtual student science symposium is in March, so they could get some feedback from people, adjust their poster and their presentation, submit it to the virtual science symposium, get some feedback, and then be able in the spring, usually do the SRS in May, June, kind of based on college. It's awesome when you can use a college campus because the costs go way down. So it tends to be in May, June. So they would have 3 chances to be able to present. 2 of them made better by that. The other piece that is really pretty cool is that teachers that are involved in the GLOBE program, NASA has internships both for teachers but also for students that are reserved only for GLOBE. So, you know, you might get a stack of applications for interns this high for other ones, and you might get a stack this big for GLOBE, right? And they have to take somebody out of this stack, right, before they go to the other stack. So there's some great opportunities around that. So around here, we've had, for the most part, I think people have gone to NASA Langley, just because Virginia is closer than GPO. So I put this up here because that's a benefit of being a GLOBE teacher. We also have some other cool things that are happening. So, I don't know, I really missed this slide. You know, one of the biggest changes, I think, one of the most important changes to our new science standards is how we look at the carbon cycle. So while we're very interested in climate change, the one piece that really contributes to that is carbon. And so partnering with the University of New Hampshire, Globe has a really very cool way of getting at this carbon cycle and teaching it in a way that I think is really meaningful to students, including collecting local data that helps them understand that. There's a current NASA mission right now that it's called ISAT-2 that's measuring the height of every object on the surface of the Earth. And so Globe Trees has citizen scientists going out and actually recording the height of trees to be able to calibrate the ISAT-2 mission. So lots and lots and lots of things done that way. Urban heat island effect or urban heat island campaign. The whole idea that even though we're only separated by 45 miles or so, downtown Buffalo to the downtown village, Fredonia, the impact of temperature in an urban setting versus a rural setting is dramatic. And so that urban heat island campaign is, I think Globe has really contributed a great deal to the understanding of urban heat island. I talked a little bit about the mosquito campaign before, but Globe Mission Mosquito, looking at these, identifying these mosquito-borne, vector-borne diseases from mosquitoes and trying to look at that. Climate change and the shift, you know, we have much higher rates now of diseases that are really pretty dramatic. So Eastern equine encephalitis and West Nile and all that are on the rise. Zika has been found as far north as New Jersey. So that campaign has contributed to that. My NASA data is a spin-off of Globe Mission Earth, which is at the University of Toledo. So NASA is supporting this, but my NASA data is all the data that NASA has collected, but now put in the same frames as Globe did. So they took a Earth system sort of idea, but now instead of just having, not just, I shouldn't have said that, the Globe database, student collected data, but now there's a parallel that matches all the NASA data that they collected from satellites. So it's a really nice way for teachers to be able, and students to be able to connect the two together. The Aaron project is using kites and low altitude imagery to be able to connect Globe with that. So take up, I refer to them as real kites. You don't, like Fredonia, there is always a wind in Fredonia. There are days we cannot fly because it will just about take your hands off. The wind is blowing so hard. They're 9-foot spans for the kites. But what's really great about the Aaron project is there is a huge engineering piece attached to it. So it is all intended to be, the parts are 3D printed. The technology, the Aaron technology, the AeroPod is a NASA licensed technology. So if you are trained through the Aaron project, you get free access for that. You don't have to ask for permissions, but the students can design and build pieces to take up onto the kite. So very cool. And then the other idea, the kind of the icon in the middle, was ways to be able to recognize students as researchers. The outgrowth of this was an attempt, UCAR, University Center for Atmospheric Research, put together a proposal to NASA to fund Globe partners bringing together groups of high quality educators, movers and shakers, to be able to think about how we could extend Globe beyond kinds of things that we've been doing. And so this Earth Systems idea where you're trying to collect the air, the water, the land, and life on the land together. So we are one of 7 Earth System Science collaboratives around the country. Very fortunate to have incredible colleagues like Dave Henry be part of that. Our focus is trying to figure out a way, and this was a great idea pre-COVID, of trying to connect what the DEC does with what Globe does, with what career and technical ed has to offer, and then taking advantage of just the incredible teachers that are involved in the Master Teacher Program as a model. So we are very focused on just Western New York with the idea that we might be able to build a case study in how it could be replicated. So, well, I don't know. I think I had 5 minutes left. So here's our team. Dave Henry, Paula Ferneza is representing CTE. Janelle Ray was representing CTE until she became my dean at the beginning of the summer. Mary Roman and myself. So they just gave me the 5 minutes. I was really hoping they gave me 5 minutes because the one time they gave me 1 minute.
And I talked for 90% and then gave them one.
Yeah, I've learned that. That's the one thing I've learned. Dave and I have presented a lot together. I have decided that when Dave says I'll go first, that takes all the pressure off. A lot more valuable when Dave shares than pressure.
Not true.
So Mary,
Yes.
ask some questions.
Do you have a question?
You do, great.
This seems amazing and very hands-on and engaging for students. I wonder if there's a focus for urban schools to participate.
Yeah, so Dave gave me the opportunity to do a Gold workshop up here as part of the Master Teacher programs, and we had high levels of interest from Buffalo City Schools. It was one of their administrators that came that day to talk to me. I think we have great success in urban settings in other places. So I think if we found we were making great strides. I think we flipped. We have a different person in charge of science now in Buffalo City Schools. So it's probably time to be engaged with that conversation. But it's the really interesting thing about it, Mary, is that we don't have nearly the amount of data from urban settings that we really use. So I was focusing about the urban heat island effect, which is really important. But one of the other ones that we talk a lot about is air quality. And so having the ability to be able to monitor air quality on kind of a continual basis, there's some technical challenges, but I don't think they're difficult to overcome. But that would be, I'm really hoping that we get some buy-in. The price is right. That's the other thing. It's funded by NASA, so it's really, I tell anybody that reaches out to me, I tell them I don't work for free. So you have to buy me a cup of coffee in the morning. If it's a full day workshop, you got to give me a cup of coffee in the afternoon. So, Julie.
So if I was a urban middle school teacher and I wanted my students to be student scientists, what would be like the most simple bite-sized thing that they could do?
Yeah, the simplest thing would be cloud protocols. So we actually, 2 or 3 years, the master teachers ran the climate summit, and we did the cloud protocols with students that attended there. It's really, really simple. It's a free app. You put it on any smart device, they can go out and automatically, and it's a really important issue for scientists, because the difference is we get climate change, we get less puffy clouds and more of those cirrus wispy clouds. And that cirrus wispy clouds are what actually trap heat energy toward the surface of the Earth. So, yeah, clouds would be really simple and important too. So.
And then could they go on that trip?
Absolutely. No, absolutely.
Because I just think that would be such an easy sell if you say, download your cloud app, look at the clouds, and then you get to take some of your super motivated students to this thing for free.
Yep, they put a poster together, right? So you have a poster to display, and we have all kinds, happy to help them any way they can.
Yeah.
to
I
put that
have
post.
one